just going to get started here. Am I smooth? I look okay? My restream is not very smooth. How do I look? YouTube preview looks smooth. Oh, hi, Beata. Oh, hi. How's it going? How's the audio sound? I turned it up a little bit because I think people say I'm quiet. Good afternoon, DCD. After I got right in the right channel here. How's everybody doing? I think you can see and hear me if I'm in the camera. Sounds fine. Awesome. Thank you. I think we're good. Hello, everybody. My name is Scott. I go by Tanut online, and this is a deep dive. I do these nearly every week at 2 p.m. Pacific here on Fridays. I work for Adafruit on CircuitPython. Adafruit is an open source hardware and software company based out in New York City. I work remotely for them, so I'm here in Seattle with my office space here and all my stuff. I work on CircuitPython. So CircuitPython is a version of Python designed for little tiny computers called microcontrollers. And I will just unplug this one that I've got here. This is the one I thought we'd talk about today because it's quite exciting. So this little teeny tiny chip here is the nRF54LM20A. It's funny because there's actually another nRF5340 here on this dev kit that's being used as the debugger. But yeah, so this little tiny chip runs CircuitPython. CircuitPython is a version of Python, a programming language designed for microcontrollers. As of today, did I get it working yesterday? As of today, it shows up as a USB drive, and you can edit code on there, and it will run. So this is a brand new board I just got. This is not made by Adafruit. This is the Nordic board. So Nordic here. They make these chips, and then what Adafruit does is we take chips that we could get on dev boards, and we make our own dev boards. So because we make like a dev board ecosystem, I guess usually it's an ecosystem. Sometimes it's little neat things like this. So this is it's named an Edge badge, but it was also known as a pygamer, and it has a little screen. And on here, it has an Atmel chip and feather headers. So Adafruit makes development boards like this for making all sorts of projects that you want. This is for gaming and specifically. But CircuitPython is meant to make it easy to use the boards that Adafruit produces and sells. So Beata said video is okay from here and audio is decent. Hello, Hams Labs and VP Tech Ops. Welcome, welcome, welcome. So this is a deep dive. I showed you a little bit about what I'm working on already, but this is a chance for folks to ask me questions if they have questions about CircuitPython or, I don't know, electronics, Zephyr in general. I do this most weeks. Housekeeping thing is I will not be doing it next week because I will be out of town or on my way back into town. We're taking a short trip, so Tim is going to fill in for me. Tim is also known as Foamy Guy. And he's started doing deep dives regularly on Tuesday mornings as well. So if you want to follow Tim's deep dives, he'll be on here Friday in this slot, but also Tuesday mornings as well. It's like 11 Eastern, 8 a.m. Pacific. So I haven't actually been able to watch him myself. But yeah, so what I do in this deep dive time is I just go over what I've been working on and talk about it. So I guess I'll start where I already kind of started, which is with this new LM20A. This is not it. I actually need to get myself another browser window here to show you. So let's just talk about the LM20A a little bit more here. This is the Nordic page for it, and it's got more. So the Nordic chip that we currently use is called the nRF52840, and it is kind of in the same class of like, we wanted something that's Bluetooth capable. They're actually they're very good at low power. And this is a new one coming in that is pretty interesting. So 2 megabytes NVM. So the reason this doesn't say 2 megabytes flash is because these chips, the nRF54Ls, don't actually use flash. They use a thing called resistive RAM, which is non-volatile. So that's interesting. So the internal, not flash, is 2 megabytes, and then there's 512K RAM. So that's like your volatile memory. So this is double what the nRF52840 has. It has high-speed USB, which is exciting. There's also an nRF54L15 and lower cost ones, but they do not have native USB. And then what's also interesting is that there's a version of this one that has 66 GPIOs, which is more than I think the nRF54 comes in. So this is a pretty interesting chip for us from Nordic. There's also a high-powered one, nRF54H20. I don't actually want to switch to the tab because it's in a different browser. Oh, sorry. We'll just Google it. And by Google, I mean Kagi. So this is the highest power version of it, the nRF54 series. I don't know why it's not telling us. It also has high-speed USB. I don't know why. Where's the thing that says? So this browser's a little large. There we go. If I just zoom out a little bit. So it's got multiple M33s that are up to 320 megahertz. So this one is definitely faster. And we actually already have a board definition for this. The tricky part about the H20 is that it is 1.8 volt GPIO instead of 3.3 volt. So the LM20 is like this nicer, so it's like, this one is dual ARM cores, and it also has RISC-V cores as well. It's like pretty complicated, whereas this LM20 that just came out and I just got my hands on is a single core. It's not as fast, but it has like still a good amount, more RAM than the nRF52840, and it has USB. And it's actually high-speed USB. It's not just regular full-speed USB. It also actually has a RISC-V coprocessor, which is interesting as well. I don't know how we'll use it, but yeah, very, very interesting. So I had subscribed on DigiKey to buying these dev kits and got an email that said like, hey, the dev kits are available. And so I just got them yesterday in the mail. I've got 2 of them. This is one. I left the other one in the box. But yeah, so this is I thought it was interesting that Nordic has stopped doing the Arduino layout on these dev boards now. They're just doing these like double row ones, and they're labeling the ports. Just kind of interesting. Sorry, I'll show you that. So they have just like this kind of like boring, no Arduino shape sort of thing. Like from here, there's 2 USBs. One is the debugger USB and one is the native USB for the chip that's way over on the other side of the board. And then there's all this I/O in the middle. There's a few buttons, and then there's a few LEDs up here too. And then this thing hanging off here is for NFC, which we don't currently support, but I have it on there anyway. So yeah, this is definitely something that we're interested in. High-speed USB is interesting too, but the chip itself is not that fast. So we'll see. So what I've been doing is getting this brought up in Zephyr. So Zephyr is a real-time operating system I've been working on, and it was all kind of inspired by Lady Ada asking me, like, how can we make it easier to bring up new chips? And Zephyr is this real-time operating system, like I said, but what they're also doing is they're trying to build uniform APIs across chip vendors. So chip vendors are going to Zephyr and adding support for SPI and I2C and displays and all these things in USB all in a uniform way. And so it makes it relatively easy to bring up a new board or even a new chip family. So the challenge we've always had is that we always have to like deal with different vendor SDKs. We also have to deal with like, we might like need to learn specific like I2C peripheral sorts of things too. So this saves us from that. So let's just show it working. Let's go back to the desktop. So I've got, this window was a lot bigger before I started streaming. And I'll just explain what the setup is here that I have. And either we could keep working on this bug. So this is the CircuitPython serial over USB. And there's this bug where this running press is showing up, and I don't know why that's happening. Like somehow strings are getting sent that shouldn't be getting sent. This is my Claude, and it was removing stuff. So in this work tree, I've been working on getting MCU boot support. So MCU boot is a bootloader that is bigger than Zephyr, but also built on Zephyr. So I want to have a bootloader that has UF2 that can work on any Zephyr board. So adding UF2 to Zephyr, or adding UF2 support to MCU boot made sense to me. So I've been doing that. And I actually think I have it working, although I haven't looked at the code in detail, which is this wild new world of LLMs where you kind of say, I want to do this thing, and like go off and do it and see what happens. And it works, but I haven't looked at it in detail yet. So those are the top two. This bottom left one is the UART output, so debug UART output of the chip. And then this is where I can make and flash it. So if I take my board that I placed here and I plug it in, I'm going to plug in the debugger first, because that's the USB cable I have, and then I'm going to plug in. So you can see that we just got debug print output, and then if I plug in the direct connection, the top one gets connected as well. And actually we didn't get that bug didn't occur, which is weird. We are getting these warnings where I was saying, I wanted to see if we were having stuff print out that was longer than what we said it was. Text longer than length. So apparently the board ID, it doesn't look like board ID is being written correctly, actually. Which is kind of funny. Oh, Beata says, your audio is peaking a bit. Go one notch or two lower. Let's just low. Okay, I lowered it a little bit in OBS. Part of the problem is I don't know like exactly which knob is where it's peaking, and it might actually be here. I just saw red. I just did OBS volume a little bit. Let me know if it's still an issue. VP Tech Ops asks, is there a loss in performance running CircuitPython under Zephyr versus native on the boards? That's a good question, and I have not measured it. I don't expect there to be a lot of loss in performance, but I do also expect it to make it easier to better multitask better. So we have this version of, we have these background tasks that CircuitPython kind of keeps track of like, I'm doing audio output and I need to figure out when to fill buffers and stuff. But our background task system is not very good about that. So there's definitely times where it feels like, oh, it'd be nice if we have a real-time operating system because, for example, I added I2S support. I didn't get working very well, and I mean to circle back to it because it was a little while ago that I did that. But with the way that I implemented I2S is that I just started another thread that, like, whenever I need a new buffer for audio, it just runs the thread. And that, like, makes it more independent of, like, CircuitPython getting into it in time, which I'm hoping will mean that, like, all of the audio pipeline that we have in CircuitPython will run better. And then we can also think about, like, offloading display into another thread. And I'm following, so Zephyr has SMP support. So SMP is symmetric multiprocessing. So that's if you have, like, more than one CPU core, you can run things on multiple CPU cores, like threads on different CPU cores. The challenge with that is that it's only on Cortex-A's right now. So there is an open issue for getting SMP running on Cortex-M's. For example, the RP2s. Either the RP2040 has 2 Cortex-M0s, the RP2350 has 2 Cortex-M33s. Like, once Zephyr has SMP support, like, I definitely want to work on that. That will allow us to say, like, oh, like, you're doing display rendering, off you go onto the other core. And that's going to be just, like, way easier to manage with Zephyr under the hood of CircuitPython. So my hope is that CircuitPython will work better on Zephyr. I don't know the performance impact. I haven't actually measured apples to apples performance impact, though, so I don't actually know that for sure. I don't know what the, like, overhead of task switching and stuff is, but I assume that it's pretty low. Abadis says, now I want to play with Zephyr. I've always had mixed feelings about Zephyr. It is very complicated. Like, the getting started is not simple. So I kind of hope that people will start from the CircuitPython side. But then again, like, sorry, I'm going to move my mic because I want to take my sweatshirt off.
It's 2:18 p.m.
What is talking to me? Some smart speaker thought I was talking to it. It's complicated. So, yeah. The cool thing about Zephyr is that they have just, like, this website for, like, all the boards they support, which is cool. One caveat with the LM20, maybe let me just pull up the LM20 DK. Zephyr LM20. So this is, like, what the board page looks like. You can see that it's maintained. And what works. Unfortunately, they don't have Bluetooth support yet in mainline Zephyr. So unfortunately, we don't have that working right now. GPIO, I2C, I2S, which I haven't tested. LED, mailbox, networking, PWM. PWM I have not hooked up to CircuitPython yet, and I should do that. The retains memory is still only a byte, which is very annoying. USB works. So when I first started my Zephyr work, I was doing a mashup of tiny USB and Zephyr, and I finally realized that, like, I just want it to work. And there's a lot of, like, effort going into Zephyr's USB stack, and I figured out how to do it. So we don't have everything yet. So like, USB HID doesn't work with Zephyr, CircuitPython and Zephyr yet, but I'm going to circle back to USB because another cool thing about Zephyr is that they have a native simulator. So you can build binaries for Linux and then run your Zephyr code, the same Zephyr code that you would run on a microcontroller on your desktop computer, and then you can swap in the backends of like an I2C peripheral or GPIO pins and kind of inspect it that way. I have a PR that is finally ready to go. I don't know if I talked about this last week. Did I talk about the challenges of getting GitHub Actions running? I should circle back to that. But the native sim is really cool for testing. And with all this LLM agent stuff, being able to put native simulator in a loop with LLM generated code is like super powerful. Hamzad points out that both Codex and Claude Code can get you going with Zephyr. It can set up the scaffold that is needed and get to the point where Hello World or Blink will work. Yeah, the complicated parts come with kconfig and device tree, and I've been using Claude for that stuff too pretty successfully, where I'd say like, oh, make me some device tree for this thing, and it does it. The nice thing about Zephyr is there's so much existing code that's close to what you want to do that like an LLM can find it pretty easily and do that. So yeah, Zephyr's definitely interesting, and it's definitely something that I'm on board with still, is in terms of like getting support for new socks and stuff. Since I mentioned it, let me just cover the display stuff. So I was having this problem, and this is how it goes. We kind of wander during a deep dive. I was battling GitHub Actions last deep dive. Okay, so I was having this issue with the pull request for display IO, where I sometimes could install libstdl 32-bit, which is what libstdl does, like window rendering of a display for CircuitPython and native simulator. So if I run native simulator, it'll pop up a window showing like the display, the CircuitPython display on your computer. You can also, I have it in a headless mode, and the headless mode I can capture to a PNG and then use that in tests. So actually, if you look at this change that I just marked as ready for review, it's got a bunch of golden images. So like here's so the input image looks like this, but we have all these color modes. And so I have golden reference images for like the way the colors look in, I guess that's just the gradient, but then like different versions of color. That's an alpha channel that's missing, so it's just like looks like that. But you can see like how CircuitPython doesn't uses luminance for doing grayscale stuff. So that's why it's not an even line. Same here, it's not an even line. It's based on luminance, and then 16-bit color, 32 or 24-bit color, and Zephyr doesn't do like 3-bit color, but we actually do. So Zephyr is not being used to test all the different color modes that we have, but these are just all the color modes that Zephyr displays have that we're testing, which is pretty neat. So we have, this will add display support, including in the native simulator. So when bugs come up in display IO land or LV font IO land, we should be able to add a test or have our LLM add a test that exercises it and then shows us that it fixes it. So I'm very excited about this. I have a dependent change on top of this that adds I2S emulation to the Zephyr native simulator, and so adds I2S support for Zephyr. So I kind of want to be able to just like treat some of these high-powered Zephyr boards as like more powerful fruit jams, honestly. Although Zephyr USB host support is quite limited, but like having audio I2S support, I'm very excited about. In fact, if you can't see my desk is covered in development boards right now, because I just like pull up the Zephyr thing and say, oh, I want to do that. Oh yeah, I'll pick up the issue. This is called the Daisy Seed. I want to get this working. Zephyr audio for that. Somebody's gotten it working outside of it, but I think Zephyrland will be cool. DCD says, if I remember right, you submitted an issue on the GitHub Actions. Let's follow up on that, because that is what got me. So you're right. I filed this issue last week, I think during the deep dive. It says, hey, I'm trying to install this and it fails. It does work on this image, and I gave them links. I remember, yeah, I did this during deep dive. Last week was, as you know, kind of crazy. So this was a much better, I actually came in the office all the days this week. It's a regression. So they followed up with me this week, I think on Monday, and they said, hey, we couldn't reproduce it, but I noticed this like remove thing. Please try reverting that and fixing it. And I realized, you know what? I should really just isolate it. So I made this new repo, and it showed the error, and all that's in this repo, I guess I could delete it now, is literally like just the commands to reproduce the issue. And then this line's the spoiler. So I was like, oh, you know what I should do? I should like just do it separately. And it was perfect. It was like, I was expecting it to be like more complicated, and I would have to like do more of the setup stuff, bring more of the setup from CircuitPython over. But no, I'd like just those 3 lines that I said reproduced it, did reproduce it. And DCD thumbs up here. And they said, oh yeah, like we could reproduce it, but it's flaky. So try running it 5 to 10 times. And I was like, thanks for looking into it. I don't want to do that. And then they followed up and said, hey, we figured out like we can't really do a lot about it, but you could try either switching from Ubuntu 2404. This is from, so the versioning for Ubuntu is this is the year and this is the month. So this is 2-year-old Ubuntu, and they say switch to 4-year-old Ubuntu. I'm like, I don't want to do that. But then they said, oh, or you could mark Python this way, which I'm not an Ubuntu user, so I don't really know that. Claude couldn't figure this out. But they said, suggest you do this. And I said, and I added it in both places, and it's been working great. I don't really understand what it does, but it's worked well. So they got me over the hump. I said they got me over the hump, but I left it open because I don't, like it doesn't technically work. I had a few tests to fix after that. But yeah, I'm very excited the display stuff is going. I have changes for Beely GAT as well that I've just not gotten back to this week. I thought I would test them when I got these LM20s, but they don't have Zephyr Bluetooth upstreamed yet. I'm sure that the downstream Zephyr that Nordic supports has it, but it hasn't been upstreamed yet. And that's true for the H20 as well. I'm subscribed to the issue for adding the H20 support, so it'll get there. I'm not too worried about that. So that's where I'm at. I wanted to fix this bug that that extra stuff was showing up, so I wonder if I just run it again. The other thing is, I don't know if I talked about this, but I've been wanting to figure out how to better manage working in multiple work trees. I've talked about how I have the like multiple desktop setups now, or like virtual desktops, one for each work tree, and that works pretty well. But like, I like using Sublime Merge to see like all the changes that the LLM has done within a particular work tree, and it's kind of a pain to get set up. And so let me hold the thought. Hamzab asks, how have you used a Salea logic analyzer using a coding agent? I have not done that yet. The closest I've gotten, and I was talking to Lamore about this, was that I have the perfetto trace that is being output by the native simulator. So like, it's to me the emulated Salea trace. And so I want to, like, when I'm modifying things in the native sim emulator, I want this like catch-all perfetto trace to output it, and it will include traces that like a Salea would have come up with. Because I think eventually I want to like mimic the native sim harness that I've created for boards themselves. So that like I can say, here's the CircuitPython board, and here's a harness, and here's a Salea logic or some sort of logic analyzer that's connected up to it, so you can track all the signals. But I haven't done that yet. So I've been having trouble. Hey, that did reproduce the bug. I thought I had added. So tracking work trees is like I have all these virtual desktops, and I like Sublime Merge to see all the diffs. But the problem with Sublime Merge is that it's hard to make 4 different windows with 4 different work trees open in them. So like you have to open one and set it up to the right repo, and then do new window and get it on another one and pick the different source. And so I've been kind of looking at like these Git management things, and I finally found this project called gifourchette, which is, I'm sure, not how you pronounce it, but it's a comfortable Git UI for Linux, and it shows you like your local branch, your local branches, your remotes, your tags, your stashes, your submodules, and gives you the tree, but it also gives you diffs, which is what I like. And then I was like, okay, that looks pretty nice. And it also says that it's Qt that integrates in KDE, which is what I use. And it's 99.8% Python. So it's like a tech stack that I'm comfortable with. And it's all Python. And I was like, this is amazing. It's open source. It's GPL3, but I don't really care. This, I think, what I'm going to show you is the feature of open source. So I took this project, and it's showing diffs, but you'll notice it's missing a few things that I want. So let me show you. I think I have it open. Yeah, so here's my version of it. So with some LLM prompting, I've got a slightly different version of this. So what have I added? One, I have the ability to mark a main branch. And this is nice because I'm now filtering out, or can filter out. I think I added it. So you can show branches that are merged, but I don't want to see them. So I just have a toggle. So you designate a main branch, and then all of the branches, local branches that you have merged in, get hidden, which is good for me because I don't delete branches. One thing that's cool is that it does do folders for branches. So if your branch name is like something / something else, it will put them in folders, which is cool. So I added that. So that lets me track, and these are sorted by recency. So you can see like the most recent branches that I've been working on. I want to revisit, and then I want to revisit like this USB IP one, the async IO one, the RGB status one I also want to do. But like these are sorted by recency, and these are definitely the ones that I'm working on soonest. You'll see there's like Zephyr LVGL, Zephyr analog IO. So there's like, I have quite the backlog. And if you see this, Espressif released the ESP IDF6. And I was just like, let's see how Claude does that. It compiles. I have not tested them on devices, but it's gotten it compiling. And I think some people will fear for their jobs about this, but like as somebody who's spent weeks doing like updates to different like versions, it's just a huge pain, and it's not creative work, right? Like you're going to learn about what they've changed, but there's no creativity in that, because it's like, okay, I got to update it. I'm going to read the migration guide, and then I'm just going to compile it and fix the compilation errors until it works again. I'm like, an LLM can do all of that, and I don't mind not doing it. Like, it's tedious, boring work. So I have that going off on the side. Hamslab says it's amazing for the Salea logic analyzer with a coding agent. Says, I'm chasing a timing problem, and it not only is it suggesting how to hook it up, but it configures, captures, and analyzes the capture. It's a pretty slick hardware-in-the-loop workflow. Yeah, I definitely want to do that, especially, so I'm thinking about this IDF6 stuff, where it's like, oh, how cool would it be if, like, it could just load it on boards and make sure that, like, Wi-Fi scans work, right? Like, if I just had one of each chip, like, plugged in perpetually somewhere, like, how nice would that be? How nice would that be that I wouldn't need to like, get something out and run it on it? I want to think about that more when it comes to the USB stuff, because I've gotten a lot of mailbags. Should I talk about the mailbags? It's been a while since I did a mailbag. So I got 2 main packages. I'm just wandering. Sorry, before we do mailbag, let me talk about the other changes I made here, because I also made worktree support. So now you open one of the folders and then it says Git worktree, and it will tell you all the other folders that are related to that one. Worktrees allow you to have multiple folders that share, like, the Git data, and you can have multiple branches checked out in different worktrees. So this is showing the different worktrees I have: YOLO, a MicroPython one, which is old, left field, tiny bytes, and then this is for the original. So now in this one window that I can have open on all my desktops, I can say, okay, here's the changes that are for my OG one. So I can look through all the changes here. And it's mostly junk that I should delete. There's one staged thing here, and time is turned on. That'd be nice. If we want to look at my changes for BLE, and you can see here it shows up in the graph as well. And then IDF6 changes, we can see it's slightly different. If I hit this, I get the branch. If I hit the top one, I get the one above. That's like all the changes. Yes, I'll make my screen bigger for mailbag. Thank you. Good reminder. So worktree support is really neat because now I don't need to manage. I can just have one window that lives across all of my virtual desktops, and I don't have to worry about, like, opening different versions of each of them. And in fact, I feel like I use the diff view more than I use like a text editor now, because I'm more interested in, like, one terminal window for the LLM and seeing the changes as they come in. So that's what this is really nice for. So here's boot changes. Somewhere in here is the definition. Here's another thing. So, like, I don't really like how they're, like, truncating, like, collapsing these in the middle. I'd much rather just have the suffix, like the things on the right-hand side, or maybe a tree view. Like, that's something like Claude could totally handle for me, is like, when I'm doing this, like, change the way this is listed, and that would be super cool. So I think that's really the future of open source, is like, you build this solid project, and then people can take it with their LLM and make it exactly what they want, the way they want. I think I have pushed my changes, but they're not to my main branch. DCD has found my fork. I think I did push them, because I did actually make a I did also make a discussion item that they haven't got back to me on, but I said, like, hey, do you want this stuff? But yeah, so it's not on my main branch or my master branch. It's on my tannewt branch. So yeah, that's where. Tyler says, fancy chucking me a side-by-side markdown diff in there too. I was thinking about making a bookmarklet for GitHub diff view earlier, the rendered version. You are welcome to do that. You are welcome to have Claude do that for you. it's been quite successful. The only time that's been kind of a pain is that the tests that are existing in this repo pop up windows. So if like Claude's off, like making sure the tests work, it's like constantly like stealing your focus, which is annoying. But yeah, it's been working great. I'm quite happy with this project. So thank you to the person who made this project in 2020 and has kept working on it. It's perfect for what I need. I think I might even started a version of that. A couple other things I want to add to this is GitHub integration. So if one of the branches is associated with a pull request, I actually just want to see like this should be my like source of truth of like what the state of all my branches that I'm working on are. So that would be cool to see there, and then CI status as well. So like, because our GitHub Actions is so slow that it would be nice to see that here too. Zephyr displays. Okay, so we've got about 20 minutes left. Let's do mailbag, shall we? Ty says, haha, thanks. That's what I love about open source. You want it, you got it. Yeah, and I think it's important to say that like it's not just that it's open source, but that like it's well structured, well documented. And this is true for like building on Zephyr as well, is that it's got a lot of examples, it's got a lot of documentation, everything's laid out well. So the LLM doesn't need to generate a lot new. It can just like mimic the way that other things work. And it can find like the relevant things by just doing random searches throughout the code base too. So yeah, I think it's really interesting. And how does that inform like where we go with CircuitPython in the future is interesting too. Of like, I think there is a lot of value in starting with something that's close to what you want, right? Like I didn't have to think about all of the other things that this app do, right? Like I never had to think about getting the graph rendering working or whatever. I never had to learn the Qt framework that they're using from Python. Like there is value in having this shared project that now I'm building on top of, like because people have thought about like interesting features, right? And that's still true for CircuitPython as well. You're not going to get rid of CircuitPython or these other projects completely because there's value in having thought about these things that you want. Okay. Since we're going through an assortment of stuff, let's go to my camera and let's do mailbag. So I got two main things, two main orders this week. One is from M5 Stack. It took a little while to get here. But the reason that I did the order straight from them is one, they just came out with this, and thanks to Mithro, shout out to Mithro who pointed me to this. This was something I was thinking about designing myself, and then Mithro, Tim, pointed me to this. This is the Unit PoE P4. It's a P4 based board power over Ethernet. So it has Ethernet to the P4, and then it also has two USB ports, one for programming, one for host. And so this is what I can use for my future hardware in the loop world, minus the logic analyzer stuff. But this is how I can isolate a dev board on the network. So I can plug a dev board into this, and I want to put firmware here to convert to provide USB IP access. So instead of having a big tree of USB devices straight to my computer, I have a bunch of these that convert like smaller chain of USB devices to IP. And then that IP is like I can basically talk to a server that says, hey, I want to like connect to an S3 right now and load some firmware on there. Here's how I do it. And as I'm saying that, it makes me think like, oh, I should have another kind of like controller thing to like blip reset lines and stuff too. Would be interesting. Which is kind of what the Octoprobe does. So yeah, I got these. And I got more than one. I got 4 of them because that's very interesting to me. That's not from the mailbag. So since I made an M5 stack order, I got the computer that people have been working on CircuitPython for. It's got the like keyboard built in that I'm not sure if it works. The dial, because I'm always thinking about improving my input. How do I work with computers? Because I do it all day, every week. Let's see, is that everything for M5? No, I did also get, and I haven't even looked at this yet, I got another tab 5, and I got another tab 5 because I wanted to, 251201. I wanted the one with the newer screen. So hopefully this one has the newer screen on it. It doesn't actually, on the back it says it's the old one, but somebody popped up an issue that says like this back, it has not been updated, but the actual device has been updated. So hopefully the new screen's there and we can test that. Tyeth asks, do they have power bus control for the downstream USB OTG port? The Dial's RF reader is great. I don't know if they have power bus control. I have not. At some point, I'm going to circle back to this USB IP stuff for USB testing of Zephyr, but I have not gotten there. I think the UF2 stuff is more interesting, which I didn't actually show, but I've started to get it working. Okay, so that's the M5 stack stuff. I don't see any other stuff over here. I got these off Amazon. These are the Modulinos from Arduino, and these are interesting because they've got STM32C0s as like little tiny controllers for like the knob. So it like converts rotary encoder to I2C. And this is something I've thought a lot about, of having peripheral microcontrollers that you can control from CircuitPython. So I picked up a couple of those. I just collect dev boards. DigiKey order, nRF54LM20s. I got 2 of them because I frankly don't know how available they're going to be right now, because this I think is like one of the first batches. Like I said, I subscribed to like when it was available. Oh, I do have more. From M5 Stack, I also got their paper S3, which I think Lucian was starting to get working but never managed to. So like I said, this is like what I do for my business, is getting all these working. So I think of these as having them here is helpful. In that vein, the xteink 4 is something that we just had CircuitPython support added by Blitz City DIY. And the cool thing about this is that and I actually have this open. So it's a little e-reader that I have not loaded CircuitPython on yet. But all you have to do is plug it into the device, and it's like the programming port for the C6, C6 in here. So it's like pretty easy to load, I think. But the interesting thing to me is that it's got, so here's my phone. My case has magnets on it. So this is like to hold on. But it also, I don't know where the magnets are. They have magnets. So it's designed to fit on your phone. It's upside down for my phone because of where my camera bump is. That's right side up. But I think this is really interesting too. This is like peripherals for a phone that uses MagSafe to like go with you. I think it's actually quite interesting. It definitely makes my phone heavier, but it's like kind of like another accessory that I think is kind of neat. So I picked one of those up as well, and I'm not done. Let's see what. Ty says, only because I know Adafruit's USB host Featherwing has 5-volt USB VCC control. I was trying out U-Hub control for switching individual ports, but all my hubs switch data, not power, and those are expensive when found. Yeah, I'm not sure. So then this DigiKey order, this is the ST definitely does it. They subsidize their dev boards. So this is an STM. This is the Nucleo. It's a C562, which they just released. So this is really interesting because it's a like very inexpensive board that has USB on it. There's no Zephyr support yet, so I'll have to wait for that. But I saw somebody from ST say that they're already working on it, so it'll come. And then in ST vein, I also got a Nucleo U3C5. U3C5. Like this board and the previous one are like 20 or 30 bucks. And I just like, especially, this is why the Zephyr work is dangerous to me. It's because, oh, like ST's good with Zephyr, so I know that like I'll be able to just throw like CircuitPython on pretty much any ST board and have the basics just work, which is pretty great. The other people, and I see this on my desk, this will be the last one, I think. But I also have this, I think this is from a previous order. Actually, you know what? I think I have a bigger stash from a previous order, previous DigiKey order. But this is the IMX RT1180. NXP made a, they call it a freedom board. And they're kind of doing the same thing as ST, is like these relatively low costs, subsidized dev boards for even their fancy stuff. So like, look at this chunky thing. It's got 4 Ethernet ports. I have no idea why. Maybe like one use is that you could use it for Ethernet. But yeah, that's kind of hilarious. It's got 4 Ethernet ports. I didn't think they were going to be all Ethernet. But yeah, so this is the NXP IMX 1180. I think it's clocked at like, it's at like 800 megahertz or something. If we go to supported boards and shields, we can do the 118 and it will show us, this is the board. Oh, you can't see. So this is the board I just held up. And yeah, 800 megahertz M7, 300 megahertz M33. That's interesting that they didn't upgrade the M7 to an M85. I think the M85 is like the newer, is the replacement for the M7. It's got 1.5 meg of SRAM, 0.5 meg of tightly coupled memory, and 1/4 meg for the M33. It's got Hyper RAM, Hyper Flash, QSPI Flash. So the Hyper ones are 8-bit data buses, I think, and then QSPI is 4. Oh, it's got 2 gigabit Ethernet connectors and 200 megabit connectors. 1 USB OTG, and they still have the Arduino header sort of thing too. So interesting. Runs the M33 is the default bootable core, and the M7 is the one that. Interesting. Huh. Yeah, these boards are complicated. Wilderness Labs have been using the F7. The STM32 F7s. Yep, so I, like, if you can find a board, I don't know if Wilderness Labs is on here. No. Ooh, WCH. WCH has some interesting stuff too. Most of it's not on here though. So yeah, that's my mailbag tour. Do folks have any questions? I'm only deep diving for an hour now, so we've got just five more minutes or so. Any questions about anything I talked about so far, or stuff that I didn't. Anybody have suggestions for PoE routers or switches? I'm very curious about that too. I've got all sorts of stuff, all sorts of dev boards. I think I had trouble getting this going, but I could probably get this going. This is a STM32N657, which is one of their new ones too. N657 is, it doesn't say. High-speed device only, OTG full speed. Ethernet. USB. XSpy. I wonder what XSpy is. Oh yeah, so it's an M55 at 800 megahertz with 4.2 megabytes of RAM. Holy moly. I wonder what the cheapest, I didn't realize they had one with that much RAM. I wonder how cheap you could get it. 800 megahertz is kind of a lot. 4.2 megabytes RAM. That is a lot. It can do H.264 encoding, supporting frame rates of up to 15 seconds at 1080p. Dedicated hardware accelerator ensures fast and simple JPEG and motion JPEG. Oh, okay, so let's go here. I really like these tables that they have. And I say that I like them in the, oh here, these tables are really helpful. So all the different variants have 4.2 megabytes of RAM. I wonder what DigiKey says the price is. I also look at JLC, because as far as I'm concerned, I just want to order everything. STM32N6, do you think they have any? Yeah, they do. How much are they? Oh, come on. So many different scroll bars. $18 if you buy 168 of them. Not cheap. Not cheap at all. $22 in singles. Yeah. Oh yeah, with the Arduino Modulinos, it's like Seesaw. Yep. So are you thinking a similar client-side CircuitPython library, or did you get them to explore creating your own? The reason the C0s are so interesting to me is that they have, ST has really strong bootloader, ROM bootloaders, and they have I2C bootloading. So in ROM, so you can disable it, but you can't brick it. Which I think is really interesting. I really think that there is this, I say that this is really interesting, and yet I don't actually understand why it's, like, what exactly it's useful for. But this idea of like having peripheral microcontrollers that you load a library on it and it brings a firmware blob along with it. One thing I was thinking about for the knobs in particular is whether you could invert the way that I2C works and have, like, when you twist a knob, it does a write to something else. So that you would have, like, instead of having to pull, if you have like 6 knobs, right? Like the way I2C traditionally works is that you would say, I have to go to each one and say, are you ready? Are you ready? Are you ready? But there's this multimaster mode of I2C where you could actually make like the 6 knobs masters, and then whenever you twist the knob, they do a write to CircuitPython. And so you don't have to poll anymore, you just write to CircuitPython. The problem is that you have multiple masters that might collide. And I did have a realization that I think i3C is trying to fix this as well, which the newer chips do have as well. So we'll add i3C support to CircuitPython at some point as well. So yeah, I like the other thing I had in mind for this like external, particularly ST chip, but just an external chip you can load over I2C, is I have, I don't know if you could see them in the video, but I have some old keyboards. Yeah, they're like right here, like old Yamaha keyboards, 80s and 90s era, where they've got, you know, big key matrices for like pressing all the things. And I really thought it would be cool to basically cut the ribbon cable and put a microcontroller between each side of the ribbon cable. So you still have all the original electronics and the like sound synthesis chip, but now you can like inject key presses and log all the key presses and like play them back or like mute them as well. And you could also like use it to make a MIDI keyboard out of it. So, yeah. So that's a project that I thought would be really cool as well. And I think you end up having to need like an I2C like microcontroller to do it. So yeah. I don't see any other questions. VP Tech Ops does say that I've been happy with Netgear PoE switches. Thanks for the suggestion. I think I've got one that's a Ubiquity one, but I'm not sure it would work here because I don't have a Ubiquity thing here for that. So I'll think about that at some point when I get back to the USB IP stuff. But yeah, thank you all. It's been a pleasure chatting with you about all the different things. I didn't even cover any of the hardware stuff. But lots going on in my brain. I'm out most of next week. I'm only here Monday, Tuesday. So thank you in advance to Tim for filling in for me for deep dive on Friday next week. You don't have to wait that long though, because Tim does deep dive on Tuesday mornings as well, to check that out. And if you want to support me, you can go to adafruit.com, purchase hardware there. They pay me to do these streams. They pay me to work on all this sort of stuff. If there's particular microcontrollers you're interested in or boards you're interested in trying the Zephyr stuff, let me know. I'm happy to bring those up so that you can try them. And thanks in advance to DCD, who usually takes time codes. And I'll do a sunny window view, and then I'll get out of here. It was rainy this morning, but it's looking nicer. Thank you, VP Tech Ops, and everybody who's joined. I will see you in 2 weeks, I think, if everything goes to plan. Oh, I should say, if you want to know more about it, you can go, or like my schedule and the changes. We have a deep divers role on Discord. You can go to adafru.it/discord to join. Ask me on there to add you to deep divers so that you get pinged if I say, hey, at deep divers, this is what's going on. Thanks a lot. Have a great